SaaS solutions often serve multiple customers or tenants from a single infrastructure, requiring careful consideration of multi-tenancy and scalability to ensure security, performance, and cost effectiveness. Through this video, I would like to explain how AccuKnox handles multi-tenancy at scale. In many multi-tenant deployments, multiple customers or tenants share the same software instances, databases, and infrastructure while maintaining data isolation. There are two ways to handle multi-tenancy. Hard isolation, where each customer gets a dedicated infrastructure with its own instance of the application, database, and everything in between. This offers better isolation, but increases operational complexity and costs. Another option is soft isolation or software-based isolation, where the database is shared and each customer or tenant has its own set of database tables, offering a balance between isolation and cost. At AccuKnox, we took on multi-tenancy as a layered approach. Layer 1, where we had to manage users, tenants, user permissions, RBAC as part of those tenants. Layer 2, where the jobs or playbook executions come into play. It is important to manage resource isolation when there are multiple demanding tenants on the shared infrastructure, and the allocation of resources has to be fair and optimal. Layer 3, where data isolation or storage isolation comes into play. Layer 4, where different tenants might have different requirements on how they consume the solution. Primarily the user experience. This is especially important in context to platform plays such as AccuKnox, where you get security solution from code to cloud and everything in between. However, not all customers would want all the features. The ability to provide custom views, navigation options on per tenant basis is key to simplified user experience. I'll be talking about specific problem statements in context to each of these layers, what AccuKnox does in the context, and some of the customer case studies. Layer 1 is about users, tenants, and RBAC, and this is table stakes when it comes to multi-tenancy. We usually run into following scenarios where the same user needs to be part of multiple tenants. For example, a customer might onboard their assets as part of two tenants, one for each department, and there could be small set of common users who might need access to both the department assets and findings. Moreover, the access permissions of these common users is tied to the tenant in which they log in. Another common use case is where an MSSP administrator needs to have visibility across all its customer tenants. Thus, the MSSP user should be able to switch between customer tenants to inspect their assets or findings. AccuKnox handles both the use cases by ensuring that a single user could be invited to multiple tenants, and the user permissions depend on the tenant in which they log in. Furthermore, for users onboarded in AccuKnox, the tenant administrators can associate access to certain resources based on labels. For example, the user can have access to assets or findings in 2 cloud accounts out of total 10 cloud accounts. These screenshots show you how accesses to the users can be configured on per tenant basis. The first instance shows that a tenant, given a tenant, a user's role can be decided to be either administrator, editor, or a viewer. In second instance, it shows that a particular user's access can be limited to specific resources that are mapped by labels. Layer 2 deals with jobs or playbook executions. This is essential where application execution comes into play. It is important to manage resource isolation when there are multiple demanding tenants on the shared infrastructure, and the allocation of resources has to be fair and optimal. With respect to resource allocation, there are two strategies. Hard allocation of compute resources, where different tenants are explicitly allocated compute resources. This provides great isolation and guaranteed execution times, but the resource utilization is suboptimal. When it comes to security scanning, there are a bunch of jobs that have to be executed for every tenant. On an average, for most customers, the job execution takes 4 to 6 hours, assuming a 4 vCPU compute instance. Thus, the compute resources would be idling for the rest of the time, resulting in suboptimal utilization. One strategy is to scale down the resources dynamically. However, even in scale down mode, the minimum resources that needs to be provisioned would be wasteful. Soft allocation provides software-based allocation of compute, and the resources can be shared across other tenants if they are idling. This usually has much better resource utilization, but one has to ensure that the system does the allocation in a fair way. AccuKnox uses a hybrid model. That is, if a customer requires hard isolation, then a separate control plane is instantiated. This is typically used for BFSI domain customers. However, for small and medium-sized customers, a soft allocation is a better strategy. For soft allocation, AccuKnox leverages Kubernetes native features for resource allocation. Each tenant has its own namespace, and certain resources can be shared across namespaces when idling. XCTM is an endpoint and network security vendor and has done an OEM integration with AccuKnox to provide CNAPP security features to its customer. AccuKnox has deployed a separate Kubernetes control plane for XCTM, and XCTM manages hundreds of customers on the same deployment. Furthermore, XCTM has a unique MSSP model that allows them to scale its operations. AccuKnox flexible multi-tenancy model enabled them to easily integrate with their MSSP model, where the MSSP users could monitor one or more of their customer assets and findings. The noisy neighbor problem is a common challenge in multi-tenant deployments, where one tenant consumes excessive shared resources such as CPU, memory, network bandwidth, or disk I/O, negatively impacting the performance and experience of other tenants. Causes of noisy neighbor issue are uneven workloads. Some tenants may generate heavy workloads, example, high API requests, large data processing jobs that compete for shared resources. Or inefficient resource allocation, lack of proper quotas or limits allows one tenant to overuse compute, memory, or storage resources. Some of the impacts of noisy neighbor problem could be affected tenants may experience slow response times, API failures, or degraded user experience. Tenant workloads can interfere with each other, leading to inconsistent application performance. Let's see how AccuKnox handles these issues. For the most part, AccuKnox leverages Kubernetes native solution for optimal or fair resource sharing. AccuKnox implements Kubernetes resource quotas, CPU memory limits, and database correction pool limits per tenant. Jobs or playbook isolation is handled by using namespace-based multi-tenancy in Kubernetes. Dynamic scaling of workloads is handled with Kubernetes horizontal pod autoscaler. However, the most important tool that AccuKnox uses for optimal resource utilization is Q, which starts with a K. Q allows tenants resources to be shared with each other at the same time, ensuring fairness. Each tenant is allocated a quota, but if that tenant is not using that quota, then the resources could be used by other tenants. The eviction logic and ensuring fairness is handled by Q. Q also ensures that if a job with higher priority gets scheduled, it gets prioritized. For example, if a user invokes an ad hoc scan from the user interface, that usually takes priority over the scheduled scans. All of these complex handling is taken care of by queue-based job scheduling. AccuKnox customer AI Dash leverages AccuKnox at scale. The Kubernetes cluster or the worker cluster that AI Dash has onboarded dynamically scales from 100 vCPUs to 25,000 vCPUs. Similarly, the container registry contains a lot of images to be scanned on a periodic basis. This could easily overwhelm the compute resources such that other tenants' workloads could starve for execution. AccuKnox queue mechanism ensures that there is an upper limit to resource allocation on per tenant basis, and there are resources available for other tenants to execute their workloads. If no other tenants are executing their playbooks, then the resources are used by the AI tenants, speeding up its own execution. This ensures optimal resource utilizations, much faster execution times, and solves the noisy neighbor problem. AccuKnox team has also shared some of these best practices in industry forums such as KCD and KubeCon. Another important aspect of multi-tenancy is how the data or storage across multiple tenants are isolated. From hard isolation perspective, one can spawn a separate database instance on per tenant basis. However, this is extremely difficult to maintain and increases operational costs as well, as results in heavy resource utilization. A deployment of MongoDB in production requires at least a 3-node deployment. Imagine having hundreds of customers and spawning a separate instance quickly becomes infeasible. Another problem statement is to limit the blast radius in the event of compromise. AccuKnox does data isolation using separate tables or collections for every tenant. This provides soft isolation and ensures that access control rules can be applied across tenants, limiting the blast radius. AccuKnox supports multiple deployment models, including SaaS, on-premises, and air-gapped on-premises. The multi-tenancy model remains the same across any of these deployment models. An MSSP can set up its own AccuKnox control plane and serve multiple of its customers by onboarding it in their own tenant. Last but not the least, provisioning user experience on per tenant basis. This is usually the most neglected aspect of the multi-tenancy deployments, but is of specific importance for security solutions. AccuKnox security solution spans multiple dimensions from cloud to containers to clusters and to cloud. However, not every customer would be using all of these services. Thus, it becomes important that the necessary or the unnecessary details are hidden from the customer views in case the customer is not interested in those services. This calls for tenant-specific user experience. It should be possible to enable or disable services on per customer basis. This includes managing the navigation options, dashboards, reporting based on tenant requirement. AccuKnox leverages Growthbook to handle tenant-specific configuration and service enablement. Here is a use case from AccuKnox customer who relies on AccuKnox only for its virtual machines runtime security. The left navigation bar reflects the use cases that are necessary for the end customer. Similarly, the dashboard and reporting options are highly customizable on per tenant basis. To summarize, building a multi-tenant solution requires architectural considerations. Security, scale, performance, and unit economics have to be taken into account. AccuKnox leverages Kubernetes native tools or models for multi-tenancy and for auto-scaling needs. Similarly, it is important to handle multi-tenancy at multiple layers, such as storage or data, execution pipelines, and user management. AccuKnox multi-tenant control plane is battle-tested by MSSPs and OEM vendors that have scaled to customers globally to deliver stringent SLAs. Thank you.